Okay, today, this is section 7 for day 1. We're going to be looking at solving linear systems using the elimination method. And first thing we're going to have to do, though, is multiply. The elimination method is the same as what we've done when we had the addition and subtraction. The only difference now is that we may have to multiply one or both of the equations by a constant term first. So again, the first thing I'm going to do is I'm going to look to see, are my equations aligned in standard form? So here I have 2x plus 5y equals 3 and 3x plus 10y equals negative 3. Both of the equations are lined up in standard form. X and y are on the same side with our constant term on the other side. And then the other thing I noticed is that the x's are lined up and the y's are lined up. So the next thing we look at is we want to see, well, what variables will cancel out, if any? And the 2 and the 3, and then we have the 5 and the 10. Well, looking at this method, we actually have to take one of the equations and we're going to multiply that equation by a constant term first so we can get it to look like the other item. First thing that I notice here is that if you look at number 5 and number 10, the least common multiple between 5 and 10 is actually 10 itself. So now I'm thinking, okay, what can I do to this 5y to make it look like a 10y? And one of the things is we could multiply by a 2. Well, if we multiply by a 2, that's going to give us a positive 10y, which then we would have to do subtraction anyways. Well, I'm thinking, what if we multiply now by a negative 2? The negative 2 is going to allow us to have a negative and then a positive 10, which will cancel out. So we're going to go ahead and take this top equation, and what I do is I just kind of throw parentheses around here. And we're going to multiply top equation by negative 2. And you'll see what happens here in a second. Now, think of this as the distributive property. Everything inside our parentheses is going to be multiplied by a negative 2. So it's just going to pretty much it's going to change the top equation into an equivalent statement. Here, if we look at negative 2 times 2x, well, negative 2 times 2 is negative 4x, and negative 2 times positive 5y, that's going to give me plus a negative 10y. And then you have to make sure that this 3 term over here gets multiplied by negative 2 as well. Negative 2 times 3 is a negative 6. And that's how the top equation has now been transformed. The bottom equation we were happy with because 10 was the least. So 10, we were okay with 10 here. What we want to do is just rewrite that 3x plus 10y is equal to negative 3. And I'm going to put that just like this. Well, now, this is very similar to the problems we just did the other day. Everything is aligned in standard form. Looking at this, we can see that negative 10y and positive 10y are going to cancel out when we add them together. So we're going to go ahead and we're going to take our addition method. We're going to add those together. So if I add negative 4x plus 3x, that gives me negative 1x. And the negative 10y and positive 10y are going to reduce down to 0, so they're going to cancel out. And here we have negative 6 plus negative 3. Two negatives added together gives me more negatives, so we got negative 9. Now we're looking at a one-step algebra problem. And the nice thing is that this process is the same as it has been for the beginning of the elimination method. So negative 1 over negative 1, well, that negative divided by negative is a positive. That gives me just 1x or x. Negative 9 divided by negative 1 gives me positive 9. So now what we're looking at is you can take any one of these equations. It does not matter which one. I like to go back to the very original problems that they wrote for me, and I like to pick one of those. I'm going to pick the top equation, 2x plus 5y equals 3. And we're going to substitute 9 into that equation. Now our goal here is we're looking to find y. So replacing x with 9, 2x plus 5y is equal to 3. Well, here's our algebra problem. We know how to multiply 2 times 9, that's 18. The 5y is going to drop down, and that was equal to 3. Well, looking at this, now we're looking at a two-step algebra problem. So we'll tee it up. We need to move the 18 over to the other side. So we're going to subtract 18. And here we've got 18s are going to cancel out. They'll add up to 0. 5y is left over here. And 3 plus negative 18 is a negative 15. Now we're looking at a one-step algebra problem. So 5 times y, I like to think of that as multiply. We're going to divide here, do the inverse operation, divide by 5, and we end up with y equaling negative 15 over 5 is a negative 3. So we found our x, we found our y. We're going to go ahead and write that as our solution to the linear system. And remember, x comes first, and then y. Now again, I'm going to recommend that you go and you take x equals 9, plug it in here to this equation, take y equals negative 3, plug it in for y, and you should simplify and solve. And to see if you get 3 for the top equation, when you plug in x equals 9 and y equals negative 3, you should get negative 3 for the bottom equation. That way you know if your solution is correct or not. So just to recap, solving using the elimination method, multiplying first, you have to first arrange both equations in standard form, and then make sure that one of the variables are going to cancel out when you multiply by that least common multiple. In this case, 5 and 10. 10 is the least common multiple, so negative 2 times 5 allowed me to turn this part right here into a negative 10, and then when I added that addition of the two linear equations, the y's canceled out, and we were left with one variable remaining, which we were able to solve and then substitute in to find the other variable.